Welcome to ETE MCQs. The problem that we are going to solve now is consider x of t is equal to e power alpha t u of minus t given as input to a LTI system with impulse response h of t is equal to e power minus alpha t u of t where alpha is greater than 0. The resulting output signal is. So what will be the resulting output signal? We are given with the input and impulse response. So let us just have a review on the basics that is required to solve the problem. The basic block diagram of a LTI system. So we have a LTI CT system for which the input is represented by x of t, the output is represented by y of t, and the impulse response h of t is given for a system. And how do we find the output? Output is nothing but the convolution of x of t and h of t. So convolution of the input and impulse response will get you the output. In this problem, we are given with the input and the impulse response. Now, what you can notice is the input is a left-sided sequence. Let me just draw a rough plot of the input. The input that we have here is t, and since it is input, the input is represented by x of t. It is a left-sided sequence. The input is a left-sided sequence. It just drops down to 0. It doesn't become 0, but it goes closer to 0. Likewise, the impulse response, it is a right-sided sequence. The impulse response is represented by h of t. Okay, your x of t and h of t is given for a system. We are supposed to find the output. If you just notice, both the signals are symmetric to one another. X of t and h of t are symmetric to one another. What I mean to say is x of t is equal to h of minus t. Both are symmetric. One is the time reversed version of the other. X of t is equal to h of minus t. We are supposed to find the output. Output y of t is nothing but x of t convolved with h of t. So how can we find the output of the LTI CT system? The output of a LTI CT system is given as y of t is equal to x of t convolved with the impulse response h of t. And we already know that x of t is nothing but h of minus t. X of t is nothing but h of minus t. It is convolved with h of t. Okay, now what is h of t? H of t is e power minus alpha t u of t. From definition or from given, what we have is h of t is equal to e power minus alpha t into u of t. Okay, so the respective Laplace transformation of h of t is given as, if you take Laplace transform on this, h of t becomes h of s, which is equal to 1 by s plus alpha. And you have a respective ROC, which is nothing but real part of s minus alpha. Since it corresponds to a right-sided sequence, put a greater than sign. Laplace transform of h of minus t is nothing but h of minus s. Laplace transform of h of minus t is h of minus s, which means that, let me call this as equation number 1. From 1 I can say that, from 1 taking Laplace transform on 1 and just applying Laplace transform to equation number 1, y of t becomes, on taking Laplace transform, becomes y of s, which is equal to h of minus t. On taking Laplace transform, it is h of minus s, and h of t on taking Laplace transform, it is h of s. So it is h of s into h of minus s. So what is your y of s? Finally, we can take the inverse Laplace transform so that we will get the output y of t. What is h of minus s? H of minus s is nothing but I am replacing s by minus s in this expression. So I will have 1 by minus s plus alpha into 1 by s plus alpha. Now this can be further rewritten as I am just taking the minus sign common throughout so that I get minus 1 by s minus alpha into 1 by s plus alpha. Now y of s is nothing but minus 1 divided by s minus alpha into s plus alpha. We cannot merge these two as s squared minus alpha squared because this s minus alpha corresponds to a left-sided sequence and s plus alpha corresponds to a right-sided sequence, both of which cannot be merged into a single term. When you take the inverse Laplace transformation, you will have one time domain term which corresponds to a right-sided sequence and the other one which corresponds to a left-sided sequence. You can just notice all the four options have got a this is a right-sided sequence and this one is a left-sided sequence. Likewise, in all the cases, you can notice that there is one right-sided sequence and there is one left-sided sequence. You cannot merge these two because s minus alpha corresponds to a left-sided sequence and s plus alpha corresponds to a right-sided sequence. So both of which has to be kept isolated until we take the inverse Laplace transform. Now let us apply method of partial fraction. We have minus 1 divided by s minus alpha into s plus alpha is equal to a divided by s minus alpha plus b divided by s plus alpha. Cross multiplying we get, cancelling out the denominator, we have a into s plus alpha plus b into s minus alpha. Okay, so when s is equal to alpha in the above equation, when s is equal to alpha in the above equation, you get minus 1 is equal to a into alpha plus alpha plus b into alpha minus alpha. This term becomes 0. So you have a is equal to minus 1 divided by 2 alpha. Similarly, let us find what is b when s is equal to minus alpha in the same equation. We have minus 1 is equal to a into minus alpha plus plus b into minus alpha. So we have minus 1 is equal to minus 2 alpha b, which implies b is equal to 1 by 2 alpha. Be substituting a and b in the partial fraction, we have y of s is equal to a is minus 1 by 2 alpha the whole divided by s minus alpha and b is 1 by 2 alpha plus 1 by 2 alpha the whole divided by s plus alpha. Now taking inverse Laplace transform, taking inverse Laplace transform, we know that this term s minus alpha corresponds to a left-sided sequence and s plus alpha corresponds to a right-sided sequence. So based on that, the inverse of s minus alpha is nothing but e power alpha t into u of minus t. This one, inverse of that particular partial fraction 1 by s minus alpha is e power alpha t u of minus t, and for the other one, for 1 by s plus alpha it is e power alpha t u of t. Okay, because this term is coined, s minus alpha is basically coined from the Laplace transformation of e power alpha t u of minus t. Okay, fine. Even in the final terms, finally, when you take the inverse Laplace transformation, you will have the time domain signals intact, e power alpha t u of minus t intact, as well as e power minus alpha t into u of t. Only the coefficients vary. So the inverse of this term should correspond to e power alpha t u of minus t. It is actually Laplace transformation of e power alpha t u of minus t is you can just trace it from this term. This is the Laplace transformation of x of t. Because x of t, on taking Laplace, it has been coined as h of minus s, equivalent to h of minus s. And this is the Laplace transformation of x of t. So e power alpha t u of minus t is minus 1 by s minus alpha. Similarly, Laplace transformation of the basic right-sided sequence. This is a left-sided sequence whose ROC will be real part of s, the pole is alpha, the pole is alpha, and since it corresponds to a left-sided sequence, you will just have a less than sign. This is the respective ROC. Similarly, Laplace transformation of e power minus alpha t into u of t on taking Laplace transform gets you 1 by s plus alpha, and its ROC is real part of s minus alpha. Since it corresponds to a right-sided sequence, it should be a greater than sign. Now, what we have is, on taking inverse Laplace transformation, we know that minus 1 by s, taking inverse Laplace transformation, I can just write the constant. On taking inverse Laplace transformation, y of s becomes y of s on taking Laplace transform becomes y of t, which is equal to 1 by 2 alpha is a constant. So you have minus 1 by s minus alpha. We know that inverse of minus 1 by s minus alpha, this is your inverse Laplace transformation. Its inverse is e power alpha t u of minus t. E power alpha t into u of minus t. For the second term, it is plus 1 by 2 alpha, the whole into 1 by s plus alpha's inverse is e power minus alpha t into u of t. So this is your final expression for y of t, which is nothing but convolution of x of t and h of t. So the final solution is 1 by 2 alpha, the whole into e power alpha t u of minus t plus e power minus alpha t into. So the option B is correct for this particular problem. Option B is correct. Thank you.